Hello, good evening. So, in this class, what I told you till our previous class that we can have two types of analysis. One is the corresponding identification, which is known as the qualitative analysis, and then we can have the corresponding quantitative analysis. So, if we get this particular procedure for any quantitative analysis where we try to know the quantity. So, quantitative analysis or quantitative chemical analysis will tell us how much quantity of iron or how much quantity of sulfur or how much quantity of any other material or metal ion is present in this unknown sample. So, how you can proceed basically? So, you can have some good knowledge of chemistry. It is not necessarily that you will only expert in inorganic chemistry, because some other areas of knowledge is also useful. So, our chemical understanding, the chemical knowledge is definitely useful to go for is corresponding quantitative analysis. So, what this, since it is a analytical method or analytical technique, so what are the typical quantitative analytical methods? So, how we can develop any method, how to use that particular method, how to apply this method to analyze any unknown sample. So, what are the things we can basically monitor, because this method will ultimately tell us about the amount of any of these composition. Suppose a organic molecule is in our hand and we want to analyze it, and the goal of our analysis is definitely is there. We want to know the percentages of say carbon, of say nitrogen, of say oxygen, and of say sulfur. So, you all know that these are the corresponding elements which are basically present in some say organic compound. It can be a solid or it can be a liquid. So, to analyze this organic compound, so this particular information we must have that we are handling something which is organic in nature, and how we can detect the presence of carbon, the presence of nitrogen, the presence of oxygen, and presence of sulfur. So, we must have to know that the corresponding method and how we can proceed from one step to another, that means the flow chart or the flow diagram which can be applied for this particular analytical technique. So, in these introductory classes we just give some idea about the corresponding flow diagram if we can have in a quantitative analysis. So, the technique is that you have a quantitative analytical method and how we can proceed from a particular step to the next. That if we can have a method, so first thing that we have to select a particular method. So, definitely we have to have a corresponding method, and at that particular methodology we must focus our attention that what particular method we will be utilizing to analyze this particular unknown sample. It can be a simple titration, a volumetric titration, such as that we use in the burette pipette case. Using burette and pipette in a conical flask, we get the corresponding analyte and some reagent we get in the burette and we titrate it. So, some rough idea we can have to select the method, then we acquire the sample. That means, these are the very typical steps where an analytical chemist can interfere to go for the typical steps. So, acquire the sample. So, if we have the sample, so this sample is there and that sample has to be processed. Suppose we get from any rock sample or any sample, industrial sample or any fertilizer sample, solid fertilizer sample, we have to process this particular sample. That means pre-treatment we call it. So, you have to treat it. So, these are very important steps. Until and unless we do all these things, we cannot get a sample which can be analyzed very nicely. In one of our previous class, the way we are talking about that if you have a steel sample and nickel is present, and suppose you know that you have some idea that nickel we can estimate from our school days knowledge by a gravimetric technique. Gravimetric method can be utilized for analyzing the nickel sample by nickel DMG method. So, the nickel DMG method is there. So, what we can do, what we learned also from our usual knowledge, that if the nickel is present in some volumetric flux or any other reaction flux or even in the test tube, we can add the reagent DMG and we get some precipitate, and from there by gravimetric method, that means by weighing the precipitate after drying at a certain temperature, we can analyze the nickel content of that particular sample. But in most of these cases, this is a very simple technique. So, that is why the nickel sample directly given from the nickel salt, such as nickel sulphate or nickel nitrate or any other nickel compound is given to you, and the solution is prepared for you, and the solution is supplied to you for analysis. But now the real challenge to an analytical chemist is that you have to develop a process where we can treat the sample, we can analyze the sample. That means, if you have the steel sample, think of it that the steel sample which is a solid one, and I want to get the nickel out of that steel sample in a solution. So, this particular step, that means how you can process the sample and is the sample soluble. That means we have to solubilize it if we go for a solution technique only, because the solution technique is very useful. You can go for volumetric analysis, we can go for gravimetric analysis. So, if it is soluble is very fine, that means we can have some measurable property. So, what is that measurable property? That measurable property we can find out if it is giving some color reaction with some reagent. That means, with DMG it gives rise to a color reaction, and if the corresponding product of that reaction, that means the nickel DMG complex which is beautifully red pink colored, so that compound which should be soluble in some other solvent, we all know that that is soluble in chloroform or any other solvent which is similar to that of our chloroform, like that of our dichloromethane. So, if it is soluble, so in solution if we can measure the color intensity. So, what is your measurable property? Your measurable property is the color intensity, and that color intensity will be directly proportional to the corresponding concentration of the nickel present in the unknown sample. So, up to this point is good. That means, if you have a measurable property, you are happy and you can proceed further to analyze this thing. But if it is not, that means your steel sample, the thing what you have tried is not able to solubilize this steel sample. So, you have to go for something which can be termed as carry out some other processes or technique which can go for chemical dissolution. So, there are large number of steps or large number of processes available for that chemical dissolution. We will slowly see that how we can process the thing. So, chemical dissolution, because in this particular case if it is a steel sample, if we treat it with some acid or some mixed acid, say concentrated sulfuric acid or concentrated nitric acid, if this acid can carry the dissolution process, that means steel can be attacked by these acids, you get the solution. But if it is not, we can have to have some other technique, that means the fusion technique, alkali fusion technique, or any other harsh condition or high temperature condition can be applied. So, all these things can come under this chemical dissolution step. So, if the chemical dissolution step is satisfied, we can reach over here, that means in the solution state, and if the solution itself is colored, we can proceed directly from there, or if it is not colored, you can we have to add some reagent, and that reagent can give rise to some coloration, and that we can measure. So, if it is yes, so then we can eliminate the interferences. What is that? That if nickel can interact with the nickel ions, Ni2 plus can interact with the DMG, giving rise to the corresponding colored sample or the colored complex, which we can measure. But if some other metal ions are also present, we all know that the still sample can have some other metal ions. It can have the chromium or any other metal ion. If those are also can interfere, those can also interfere the corresponding estimation. That means it can react with the DMG. It may not give the same color, but it can consume some amount of DMG. So, that will interfere our measurement. So, all these interferences we have to eliminate, then only we can determine that only nickel DMG can be estimated for our analysis. But if we can not have a measurable property like by simple addition of DMG, if it is known in this flow diagram, we change the corresponding chemical form. Suppose we are analyzing not nickel and some other element like that of our aluminum is present in some other source. So, your analyte contains some aluminum. So, if it is no for DMG, so you change the chemical form. So, aluminum will take some other reagent which is 8-hydroxyquinoline, that we will discuss afterwards. So, you have to go for some other reagent. That reagent can give rise to something which can interact with the species, and we can get something which is a measurable quantity. It may not be colored. It is insoluble precipitate, and if it is insoluble precipitate, that can be weigh out and go for the corresponding estimation of aluminum. So, after elimination of these interferences, what we get there, that once we eliminate these interferences, we measure the property X. So, measurement of this property is very unique technique for this, and this can be your color, this can be your weight, or this can be any other thing. So, once we measure the property, the intensity of the color will be related to something which can be considered as the corresponding spectrophotometric data as the absorbance. So, absorbance A can be measured, and that absorbance A is your data related to that of your concentration, and we get the corresponding results in terms of the absorbances and in terms of the corresponding concentration of the nickel or any other element. So, we calculate the results, then we go for the estimation in terms of the reliability of the results. That means the repeatability of these results. We should not be happy by doing some one measurement, because errors are always there if we do not have a good calibration. So, we will also learn slowly that what is called calibration. We can have the corresponding calibration curve, and how we can utilize this calibration to estimate the corresponding unknown quantity. So, reliability of the results will also tell us the corresponding estimation. So, we can go simply for 3 different measurements. So, we take 3 samples of these, 3 still samples, we go for the dissolution, we get in solution, we estimate its corresponding color and the color intensity for these 3 samples we can measure, and we take the average. If the average in our good matching range, then we can have some reliable data for these 3 measurements, and we can consider that we have reached to some estimation which is giving some good results for our corresponding estimation of our unknown quantity. So, this quantitative analysis is therefore very much important for our volumetric methods, and then we can have the gravimetric methods. Just now, as I told you, that we can have the nickel DMG complex, which is precipitating out from an aqueous medium in ammoniacal aqueous medium, because ammonia solution, aqueous ammonia we have to add. So, nickel DMG will be precipitated, we take the weight. So, weight of this nickel DMG precipitate can tell us about the corresponding percentage of nickel in the unknown sample, which is our still sample or any stainless steel sample. So, when we talk about the weight, when we talk about the volume of something which is directly proportional to the unknown concentration of nickel, we get the volumetric analysis. And if we can tag this, that means this particular technique with some electrochemical method, we can give rise to something which is known as electroanalytical method. Electroanalytical method, and in that particular electroanalytical method, so mass of the analyte we can analyze. So, this is typically a simple gravimetric method from the addition of DMG to nickel 2 plus, and as a percentage of nickel we can analyze it. But in this electrochemical methods, what we will be measuring? That means some electrical property we will be measuring. So, this is a new quantity. So, we can measure the electrical charge or electric current. So, the potential we can measure, or we can measure the current, we can measure the resistance, or we can go for the Coulomb count. That means the corresponding quantity of electric charge which is being carried out by some metal ions and all these things. So, if we have a cation, that means this Ni2 plus, the same sample Ni2 plus is there, and we all know it can be reduced by some electrochemical cell. If we can have some electrochemical cell, that is also from our school days knowledge, that if we have some electrochemical cell, we have the cathode, we have the anode, we all know. So, to estimate Ni2 plus, how you think of some process or some methodology which can be useful for our quantitative analysis, that Ni2 plus is there, and this Ni2 plus we have to reduce therefore to get nickel 0, and this particular nickel 0 in its metallic form can be deposited on some electrode surface. So, if it is cathode, so on the cathode surface, if it is there, so if you have the cathode surface, so on the cathode surface, so it is the electrode. So, electrode is your cathode, and this nickel can be deposited on the cathode. How we can think of it as the combined form of these two, that means a gravimetric analysis or an electrochemical analysis or electroanalytical method which can be combined. So, these thing is that means we will utilize the corresponding passage of electric current on some electrochemical cell, and we can have some monitor of these, how much charge, how much current, and all these things are here. But ultimately, if we focus our attention on the corresponding reduction of nickel 2 plus to nickel 0, what we see that this nickel 0 is there and which is deposited on this thing, that means the cathode is gaining its weight. So, before deposition and after deposition there will be a change in the weight of this cathode material. So, if we can get the corresponding weight difference, that means if we go for the corresponding weight change during this electrolysis process, that means the nickel 0 is forming from Ni2 plus from the solution. It is there in our solution and which is on the surface. So, this change in weight basically gives rise to a combined form which can be termed as the corresponding electrogravimetric method. So, electrogravimetric method is a combined form. So, utilizing the techniques or the knowledge of gravimetric analysis to that of our electroanalytical method to give rise to some electrogravimetric method. So, a new methodology we can follow which is known as electrogravimetric method. So, that gives rise to some understanding that how we can utilize this particular thing, that means the sample where we can have the corresponding sample. So, now we can give rise to something where we get the analysis of a typical real life example, because we are trying to understand the nature. So, we will take some example. So, definitely it is from textbook also. So, it is there in the book that all these applications, that some deer, So, is the animal, death of some animal is caused by some pathogen. So, is the toxic effect of some material. So, basically we call these as the typical environmental disaster. So, this particular thing has happened in US, in Kentucky. So, there people found that some deer, so basically if we consider that a deer park is there, and by taking or grazing grass, the deer death is occurring. So, how analytical chemistry can be useful in terms of understanding the toxic effect of something. So, toxicology, as I told you in our previous class, that how analytical chemistry is helpful in understanding the toxicological effect or the toxicology. So, power of this analytical chemistry you can utilize to understand these. So, these are the corresponding deer which is available in this park, which is a medium sized deer which is native to United States and some other countries. So, they have this white tailed deer, and the death of this white tailed deer is due to consuming these grasses where something has been added. So, we all should be very much careful what we are consuming. So, is related to everything, is related to environmental chemistry, is related to death of this thing, and when particularly we are studying the toxic effect something, some unknown quantity or unknown compound. So, this is coming under the purview of toxicology. So, the toxic effect of this compound, what we can utilize for analyzing these things. So, the toxin, why this is causing, why the death of deer is causing. So, how we can determine the toxic effect of some thing which is given to this particular park. So, white-tailed deer in a wildlife area of Mammoth Cave National Park in Kentucky, US is happened. So, this is related to something and people try to understand it in a different way. That means they call the investigators. So, investigators are asked to understand how this grass surrounding the corresponding power poles, basically the grass is there, and if we try to monitor the corresponding growth of grass, we can put some herbicide. So, they basically suspected that some herbicide has been sprayed on these grasses, and this grass is contaminated with this herbicide, and this herbicide concentration or the nature of this herbicide can be lethal to the deer. So, deer is consuming something which is getting contaminated from this herbicide, though we are utilizing these herbicides to reduce the growth of this grass in some point, and there are other types of herbicides we all know. So, if we can have something, basically this has been sprayed over there, which is a arsenic based herbicide. So, there comes the knowledge of typical chemical knowledge, that means understanding this particular compound, because occasionally we are adding for something, we are utilizing this for spraying this on the grass surface, but the compound whether is a deadly to the human being or whether it is deadly to the deer, that we all do not know. So, this is very interesting that we are talking something is arsenic, because we all know that our environment nowadays we talk about the arsenic contamination or arsenic pollution in the groundwater also, that we will discuss at some point of time, but that is why I have chosen this example, which is the arsenic based compound, and this compound is nothing but some arsenic acid. So, it is not a typical arsenic acid, because it is not a typical inorganic compound, some group is attached to it. So, is a methane arsenic acid, where a methyl group is attached to arsenic, and is not that free acid, is corresponding disodium salt. So, is AS double bonded O and OH. So, OH will be substituted by ONA, like your sodium salt. For acetic acid we all know sodium acetate coming from the acetic acid. So, if we have the methyl arsenic acid, which is CH3ASOOH whole twice, so disodium salt is there. So, this herbicide is nothing but its corresponding disodium salt of methane arsenic acid. So, we see that this particular herbicide has been converted to its corresponding acid form, to its disodium salt form. So, this disodium salt is very much soluble in water, and that is why it is an active ingredient to these herbicides, because we put in water and we spray it. So, on the grass surface it is sticking. So, the sticked grass surface is there. After evaporation of water, these compounds forming some very minute layer on the grass surface, and deer is basically consuming this particular compound. So, deer is consuming this compound, and that is why after some time or after some days the death is taking place for the consumption of this herbicide. So, basically the toxic effect of this compound on the health of the deer is the corresponding contamination, and how to identify this particular arsenic. So, arsenic is going to the body of this deer. So, you have to analyze it. So, it is a very typical task, because you get a sample of dead deer. So, dead deer is in your hand, and how to analyze the arsenic which has been given to this particular deer, that means unknowingly it has consumed this particular arsenic. And this particular thing, how we can monitor is that a very simple chemical technique, that means that we will be taking the corresponding kidney samples of these dead deer, because anything we consume we all know that is going out from our body. So, it is going through kidneys. So, kidneys of these deer are also contaminated with these arsenic samples. So, the chopped kidney samples, so the kidney samples which is organic matter, basically a fleshy matter, if we can take it in a crucible and is placed in a furnace and heated at 550 degrees centigrade for 2 hours. So, this is the recipe, this is the methodology, this is the technique what we can use to identify this particular stuff at very high temperature. So, basic idea of is that you have the disodium salt of arsenic acid. So, arsenic acid will be converted to arsenic based oxides. So, at a high temperature, until and unless we do that, so very high temperature, this also give rise to some idea that any biological sample, any living sample which has been taken as the kidney of the deer, if we burn it at a very high temperature on a crucible, because the crucible can sustain, it can be your porcelain crucible, it can be your vitreocell crucible which can sustain a very high temperature. So, all other organic matter will be burnt away, and if we burn in air, because this is, if this is the air furnace or on some special type of furnace where air flow is there, so it can be utilized for oxidation of the organic part. So, carbon will be oxidized to carbon dioxide, hydrogen will be converted to water. So, we will be leaving behind with only the arsenic. So, that arsenic will be converted to its corresponding arsenic oxide, and this arsenic oxide which is getting as As2O5. So, what we will be getting? So, arsenic in the pentavalent form. So, pentavalent arsenic is forming over this due to this particular heating procedure. So, a mass is available. So, after heating for this crucible for 2 hours, we will leave behind with some amount of dry solid at the bottom of this crucible. So, what we will do? We cool the crucible and we dissolve the particular sample with dilute HCl. So, dilute hydrochloric acid will react directly with this oxide form to give our soluble H3ASO4, the corresponding acid related to arsenic in the pentavalent state. So, we know that this anion ASO4 3 minus is the corresponding arsenate ion. So, is the corresponding arsenic acid which is giving us that arsenic which is present in the pentavalent form. So, this is there. So, we get something where we have this. So, arsenic was present. So, what are the changes? So, chemical changes, try to keep in mind that what are the chemical changes are taking place. We were having the corresponding disodium salt of the corresponding acid, arsenic acid. We are now converting this particular form, and now we are having this H3ASO4, which is coming from the kidney sample of the dead deer. So, how to analyze this? So, this can be a simple salt which we get it because this is coming from a corresponding reference of the book, which is the Skoog and West. The book is the Fundamental Analytical Chemistry book. You can go through this particular book for this particular example. So, we have reached over here. So, up to this point, so that we will discuss in our next class, that we have some toxin and we try to analyze this particular toxin, and toxin as a typical chemical compound. So, we have the chemical compound, and idea is that chemical compound, if it is some element based, the element X is arsenic over here. So, we make some oxide. So, because we are heating in air, so air is there, O2 is there, then oxide is there, and we all know that if it is dissolved in acid, we get something where the corresponding oxo acids are forming. So, we will having some ASO4 3 minus. So, our now challenge is that how we can analyze the formed ASO3 minus in solution, which is very simple to go for it, but we will use some special technique for this. So, this is related to anything which is the contamination of arsenic in our groundwater also, that we will discuss in our some other classes, that how the groundwater, if it is contaminated with arsenate, can be analyzed by using this particular technique. Okay, thank you very much.